Okay, so just a quick comment on some things with the line integrals here. First off, we defined everything for functions of two variables and for curves in the xy plane. There's no reason that we couldn't do that for functions on R3 and curves floating around in 3 space. Right? And in fact, the definition we used, this definition here, works perfectly well in 3 variables. And it looks basically exactly the same. What is this? Magnitude r prime dt. Right? Where c is parameterized by, of course, r of t, and t goes between a and b. Right? So that's, of course, always possible. It can be in 3 dimensions. Right? Another point I want to bring up is, let's say C is piecewise defined. So C is piecewise defined as, what's a good notation for it? Let's say defined by multiple curves. C1 through Cn. Right? So what do I mean by that? What I mean is maybe C looks something like this. Right? So you have this piece C1, this piece C2, this curved piece C3, and this wavy bit C4. Right? So maybe you have something like that for your C. Well, no matter, because then the full line integral, in fact, let me even leave off the of x, y stuff, because this, again, works for any number of variables you want. Let me just write f ds. Well, all we have to do is integrate over each curve separately. Right? No big deal there at all. Okay? Now, there's also a nice application that we have for these guys, right? For line integrals here. So we could also say, suppose a thin wire is bent in the shape of a curve C, and has density. So this is like a linear density, rho. Okay? Then the mass is given by just doing the line integral of the density along the curve. Right? And then we can also, of course, find the center of mass. Right? So then the center of mass has coordinates x bar, y bar, z bar. Right? This is given by, well, we have an integral for each component here. Right? So x bar is going to be 1 over the mass times the integral along C of x rho ds. Right? And then likewise for the y and z coordinates. Y bar will be 1 over m, integral over C of, oops, not x, y rho ds. And the center of mass, the z coordinate of the center of the mass is 1 over m integral over C of z rho ds. Okay? All right. So these are just some comments here about line integrals.